Here, our last example from Module 7, we have a bunch of different things we're going to find, so hopefully this will sum up a lot of the probabilities that you've been asked to find and you can distinguish between them. In this example, the following data represent the survival data for the ill-fated Titanic voyage by adult male, adult female, and child. If a passenger is selected at random, what is the probability that the passenger survived? Okay, so we see that our rows represent whether or not the person chosen survived based on male, female, or child, or if the person died. Okay, so for the first one, the probability we're looking for that we have somebody who survived. Well, that's going to equal, we have a total of 711 out of the 2,224 that were on board, and this gives us approximately 0.320. Okay, going on to B. If a passenger is selected at random, what is the probability that the passenger was female? Well, from our table, the total number of females was 425 out of the 2,224 on board. So that gives us approximately 0.191. For part C, if a passenger is selected at random, what is the probability that the passenger was female or a child? Okay, the probability that a passenger was female, let me stay consistent with my notation, female or a child. Well, these two things are independent, the way that it was defined. They did not classify the children as male or female because we were told female represents adult female, male represents adult male. So since these are independent, we just find the probability that the passenger was female and add to it the probability that the passenger was a child. So for the probability of being female, we already found that one, but let's go ahead and write it as a fraction. 425 out of 2224 plus the probability that someone was a child was 109 out of 2224. So that will equal, let's see, 534 out of 2224, which will be approximately 0.240. Part D. If a passenger is selected at random, what is the probability that the passenger was female and survived? Okay, so the probability that the passenger was female and survived. Well, we don't know if these are independent, so we're going to use our general multiplication rule. So that means we're going to find the probability that the passenger was female and multiply it times the probability that the passenger survived given that the passenger is female. Okay, well, the probability that the passenger is a female we already found to be 0.191 in part B. Well, the probability that the passenger survived given female, we need to use our formula that we learned in this lesson. So we need to find the probability that the passenger was female and survived divided by the probability that the passenger was female. So we keep our 0.191. Okay, so what is the probability that we had a female survivor? Okay, so female survivors were 316 out of the total of 2224, divided by the probability that it was a female. Okay, well that was our 0.191. So those are going to cancel out. And when you do that division in your calculator, 316 divided by 2224, that will be approximately 0.142. Okay, going on to the passenger is selected at random. What is the probability that the passenger was female or survived? So the probability that the passenger was female or they survived. Okay, well we need to use our general rule for addition in this case. So we need to find the probability that the person was female plus the probability that the person survived, and subtract from it the probability that the person was female and survived. Okay, well all of these values we found earlier. So for the first one, and let me write it underneath so that it's clear, the probability that a passenger was female was 0.191, plus the probability that the person survived was 0.347 approximately, minus the probability that they were female and survived, we just found that in part D, came out with 0.142, and this is going to give us 0.396. Okay, so let me write my squiggly lines here because we had already rounded those values. So this is just to signify it's not, it's not exact. For part F, if a female passenger is selected at random, what is the probability that she survived? So we're interested to know if she survived given that she's female. So our formula, this is what we learned today, is going to be to find the probability that she was female and that she survived. Divide that by the probability that she was female. Okay, well the numerator we actually found in part D. So that's equal to approximately 0.142. And let me be better with my approximations here. And I should have done that up here as well. Okay, divided by the probability that she was female. We found that earlier to be 0.191, and this gives us 0.743. Part G, if a child passenger is selected at random, what is the probability that the child survived? So we're interested to see if the child survived given that it was a child. So we're looking for the probability that a passenger was a child and that they survived, divided by the probability that the passenger was a child. Okay, well if we look at our table, the probability that it was a child who survived was 57 out of our 2224. divided by the probability that they were a child. Well, 109 of the passengers of the 224 were children. So when we simplify this, we end up with 57 divided by 109. So if you approximate that, you end up with 0.523. Okay, going on to part H. If a male passenger is selected at random, what is the probability that he survived? Okay, so again, we're interested in his survival given that he was male. So hopefully, with all of these, the formula or our definition is becoming routine. So we find the probability that he was male and survived divided by the probability of the passenger being a male. Okay, so looking in the table, you'll see that 338 of the 2224 were men who survived. And there were a total of 1,690 men out of the 2,224 passengers. So when you simplify this, you end up with 0.2. Okay, for I, do you think that the adage, women and children first, was adhered to on the Titanic? Okay, well, if we look at the last three parts that we did, the probability of survival, somebody survived, given that they were female, given that they were a child, and given that they were male, yes, it does appear to be true. Females and children survived at higher rates than men. Okay, so let's write that in. So yes, it appears to be true because females and children had a greater probability of surviving than males. Okay, for part J, suppose two females are randomly selected. What is the probability that they both survived? So this is where you can kind of think of it as a tree diagram. So we're only looking at females and we want them both to have survived. Okay, so we're going to look at the probability that it was a female who survived, and then we're going to multiply it times, again, the probability of the remaining that it would be a female who survived. Okay, so looking at our table, 316 of the 425 women survived. Okay, so 316 out of 425 women survived. Okay, so given that person survived, what's the probability that the second person chosen was also a female who survived? Okay, well, there are only 315 left. And in the bottom, only 424 women who are left. So when you do that product and simplify it, you should end up with 0.552 approximately.